Hello and welcome to the Mr. Jones Science Show. Now I know I've been doing lots of special effects with these videos, but if you thought that this water instantly turning into ice was some sort of special effect, well, you'd be wrong. This is done with just science. And if you watch this video, you'll know how to do this same thing at home, and then you can try to do your best Elsa impressions or your best Frozone impressions as well. So let's get started. All you need for this experiment is some purified water and a freezer. Now the purified water is important. You can't just get any regular tap water or even some bottled water that has lots of minerals. Can't be used either. And we'll talk more about that later on in the video. So once you have your purified water and you have your freezer, you stick your water into the freezer. You make sure that the water is equally spaced out, not all on top of each other. And then in a couple of hours, your experiment will be ready. But there is a precise amount of time that you want to leave your water in there for. So wait on, and later in the video, we'll talk about that precise amount of time. Then when you're taking it out, you got to be very careful because any sudden movements like this could cause your water to turn instantly into ice, and you won't be able to see your cool reaction. Plus, turning the water into ice instantly in the bottle isn't the only thing that you can do with this experiment. Now, you might be asking, why does this happen? Well, you might know that water has a freezing point, or a temperature at which the water starts to freeze, and that is 32 degrees Fahrenheit or 0 degrees Celsius. But the thing is, that is not the only conditions that need to be met for water to freeze like this. Water needs to be able to be cold enough, so underneath that freezing point of 0 or 32, and it needs to be able to have a nucleation site. If water is cold enough, so below its freezing point, but does not have that nucleation site, then the water becomes super cooled. And that is what happened when you first start out with the water. When you strike it against something, it is going to turn into ice because you are providing a nucleation site. See, if you were to zoom into water all the way down into its molecular level, meaning that you get to the smallest amount of water where it's still water and not something else, then when it's a liquid, you'll see all these water molecules bouncing all around, going all everywhere, going whoo, all like that. And as water starts to get colder, these particles start to go a little slower, and a little slower. And then when they get underneath that freezing point, that they really want to be able to form into the ice crystals because they're actually kind of slightly magnetic. It's not exactly magnetic, but it's close to it. And they want to stick together in certain ways. But without that nucleation site, then they're not going to stick together. Now that's also why it's important to get purified water and not just regular tap water, because something like minerals or some impurities in the water, or even impurities in bottles or cups, if you want to try to do this in cups, those could cause that nucleation site to begin. Or when you give it a strong hit, the molecules are able to align just right, and then they start to form a crystal. All those things start to kind of connect together like magnets, and a lot of the water starts to turn into ice instantly. Now you might be thinking, wait, Mr. Jones, this is not yet an experiment. All you're showing is an activity because we haven't taken any data, we haven't made any predictions, we haven't been able to do any tests yet. Well, you'd be correct. So you're actually going to get to do this experiment at home because to do this activity here, it requires you to get that precise amount of time that the water needs to be left in the freezer. And there's lots of factors that can change how much time a water bottle can remain in the freezer. So you're gonna have to experiment. So first, if you'd like to try this at home, I would suggest you to leave whichever water bottles you have, leave them in the freezer for about like an hour and a half first, and then check them. If you see that they're frozen like this, then you know that you put them in the freezer for too long. If they still look like water for the most part, then they probably still need a couple of minutes. So after that, check every 15 minutes. And if you start seeing some ice on some of them, then you know that it's about the right amount of time, and then take it out and try it yourself. And then that gives you the perfect amount of time for your water to be super cooled. Now, it's probably not gonna work out on your first try. And even me knowing that it takes roughly 2 hours for these to freeze in my freezer, different parts of my freezer freeze at different moments. So ones that are closer to where the air comes out, those freeze a lot faster than some that are further away. So at 2 hours, one is completely frozen, while some of them might or might not be frozen. And in this case, I put 6 bottles in the freezer and only about 3 were actually super cooled and didn't already turn into ice. So you're gonna have to try a couple of times before you're able to get this right. But when you do, it looks really cool. And there's also more things you can do. So, do you want to build a snowman? To build a snowman or build some ice structures, all you need is a plate and a piece of ice on there. You'd probably want to use a bowl, but for filming purposes, I used a plate. And then carefully open up your water bottle and then pour your super cooled water on top of the ice. And then you start making these crystal structures. I would suggest, unlike me in this example, for you to use some sort of insulator so that your hand doesn't get too cold, because my hand got pretty cold there. So be careful there. And there you have, you can build a snowman, you can build all these different structures. I think it's pretty cool being able to see this water kind of instantly turn into ice as you are using it. When you're pouring out your super cooled water, make sure that your bottle does not touch the ice that you've already formed. Because if you see here, I did, and then I wasn't able to pour the rest of the water out because it froze in my bottle. So, whoops. Now, if you try this experiment at home, please do not drink the super cooled water, because it's going to turn into ice in your mouth and it's going to cause some pretty major damage in your teeth and your mouth and everything. So don't drink that. But once you've turned your super cooled water into ice, whether you struck it against something or you poured it all out, then you can drink the ice that you created. That part is safe to eat. And you can even add some syrup or add some juices and make your own snow cone with all that. So I hope you've enjoyed this experiment and that you have fun trying this experiment at home. Have a great day, Ballington scientists and engineers, and I'll see you on Friday for our sharing day. Goodbye.